Hi, my name is Stacy Trey. I'm a researcher at the Research Institute of Sweden in Stockholm, Sweden. Today I'll be presenting a project proposal involving sustainable electrical vehicle motor windings by additive and manufacturing of copper. So the organizations that are applying KTH, the Royal Institute of Technology, is located in Stockholm and will be the coordinator of this project. Sasson is an assistant professor in the Department of Production Engineering. And as I mentioned before, I'm a researcher at the Swedish Research Institute in the Polymer Materials and Sustainability Department. And we are an organization of 3,000 employees with expertise in a wide range of areas. So the proposal introduction. Our vision is to reach reliable powder and additive manufacturing parameters to manufacture precise and reliable components, to create design guidelines, to develop a new generation of electrical windings that can be done with additive manufacturing, to create successful installation methods, so the plastic installation, and 4, to understand the effect of surface roughness of this additive manufactured copper, and then post-processing of it, how this affects the insulation that's applied afterwards and the performance of the part. And then to test the additive manufacturing made windings on the lab scale. So the motivation of this project is to make windings created by additive manufacturing a reality and an improvement over what is done today. So some of the challenges include the fact that the design possibilities to use additive manufacturing for copper windings is not clear. This needs to be developed. Also, the copper that is printed needs to match the electrical properties of conventional copper wiring used in motors. 2, the feedstock powder or part properties after additive manufacturing might be varied or unreliable. So the geometrical precision and accuracy of the AM parts needs to be ensured. 3, the whole coil will be formed at once by additive manufacturing, and therefore only certain stator tooth designs are applicable to the winding. Today, motors are wound with insulated copper, and then the entire stator is dipped in resin for insulation. But in additive manufacturing of the coils of the copper wire, the whole coil is formed at once, and then the insulation needs to be done afterwards in some kind of different process. The rough surfaces of this printed copper can increase the electrical stress between the copper turns, which could cause sparks and reduce the motor lifetime. The copper produced using the proposed method needs to be tested in motors, so operating both electrically and mechanically in demanding working conditions. So the expected outcome is that the motor efficiency would be improved. The estimated increase in the power could be something around 30%, or efficiency in the range of 3 to 5%, on top of the current efficiencies of about 90 to 92%. Reaching these goals means that we need research and development in this area. So impacts would be that the power of electrical motors will be increased, as well as maximum recharging distance. The project is expected to be about 3 years. So currently our consortium consists of Amnovis, a Belgian company who is a manufacturer, the designer Xylem, who is a Swedish company, and they are looking at different copper winding designs for additive manufacturing, how it can improve on the current designs. The end user Scania, and the coordinator, the KTH Royal Institute of Technology, an academic partner developing EBM parameters, and then also working on the post-process heat treatment. RISE, the Swedish Research Institute, is helping to develop the installation in combination with Solve, an Italian company. We're also using our additive manufacturing center at the Swedish Research Institute to do post-processing to smooth the copper surface and see how this affects performance. Quality control will be done with the help of KU Leuven. So partner search, we're looking for small companies in Sweden who could help with working with copper additive manufacturing, or a company working on plastic molding installation processes. In any country, we're looking for end users. Also a manufacturer for EBM and LPBF processing in any country. Or in any country, a material producer of copper for EBM and LPBF. So our contact info, this is Sasan's email, and this is my email, stacy.trey@ri.se. Thank you very much for your time.